So thank you everyone for attending this session. As already told, this will be a conjoint presentation by me, Luís Carvalho from LTP Labs, and João Sá from Sonaeraco, a company specialized in wood-based products. How are we going to divide our presentation today? I will give you a brief presentation about LTP Labs. Then João will present Sonaeraco and the challenge that they propose to us to solve together. Then we'll present the methodology, the simulation optimization model that we built.
For the camera, can you
Come in? Okay, that we have built using Gurobi. Then João will go through the main results using our solution, and then we'll go through some guidelines over the project management and change management that we followed during the project. Going to the LTP Labs introduction, we are a management consulting firm specialized in advanced analytics. We have more than 80 consultants, more than 250 projects with a growth of more than 25% for every year. One very important part: we are from Portugal, from the city of Porto. Hope some of you have already been there because it's a great place. So what sets LTP apart from the competition? We are neither a product-based firm. We are neither an old management consulting firm. So we try to combine the best of both worlds with hybrid profiles of consultants with a strong analytical power and a rich business expertise. We have also a solid background in research with a lot of people with a PhD and some research in the area of sales and operations and also production planning. So which type of projects do we usually do? Marketing and sales is one of the typical areas that we work on marketing and demand. So with a lot of forecasting projects, pricing and promotions to understand which is the impact of a promotion, not only in the sales, but then how should we plan our promotions over the following periods. How can we improve our marketing strategy by a tailored targeted marketing strategy, and also how to improve the customer insights, and then some projects regarding assortment and profitability, mainly related with retail. We also have projects related with supply chain and operations. Today we'll cover one of these topics related with production strategy by defining if which product should be made to stock or made to order, also covering the lot sizes that we have, but we also cover other areas in supply chain and operations like network design or production planning. We have a lot of partners, not only in Portugal, but throughout Europe and the other continents. We work with services, with retail, consumer goods, and with manufacturing. And one of our clients is Sonaeraco, that João will present next.
Okay. So we are a company that started originally from Portugal, but we are a multinational. We have 11 plants around the world, 4 in Germany, 3 in Portugal, 3 in Spain, and 1 in South Africa. We do wood-based panels. So these are the numbers, the employees and turnover. And we do this kind of products. So particle board, this is mainly MDF, mainly for furniture, but also for interior decoration and construction, OSB. So the scope of the project was only the German plants, and we want to expand it to the Iberian plants and to the South Africa plant, but first we have to fully implement it in the German plants. So what were we wanted to improve? We have a production strategy mainly based on MTO, and we want to increase the MTS. Even compared with the pairs, we are satisfying the demand mainly from MTO, and our competitors or industry from other industries have a much higher make-to-stock strategy. So, and then consequently, our warehouse is mainly occupied by MTOs. And the main goals we are trying to achieve is to improve our service level by being more reliable and reducing lead times, but as well stopping less the production lines, so increasing the availability. To do that, we need to increase the production lot sizes, and that we need to build, to forecast, and to stock. So that was the challenge. I think I didn't. So what were the analyses or the diagnostic that LTP made? So we want to improve the production strategy mix by increasing MTS and reducing MTO. Our main restriction is the warehousing space, so we need to find the best SKUs to occupy this space, so the SKUs that deliver more efficient operations in the lines and that contribute more to higher service levels and reduce lead times. So to do that kind of complex decision, we need analytics, because we were doing that with Excel files and 9 boxes analysis, and that goes up to a certain point. So then we talked with, and we also wanted to improve our KPIs and monitor this.
Okay, thank you as well. So I think the problem is clear, but on top of that, when we look to production, we want to fulfill the market. So one of our main goals with this project was also to connect the commercial team and the supply chain team by a tool that could connect both teams and then support the discussion of how can we address the market. So every year we have a problem that is we need to define the portfolio that is somehow something unpredictable, because the demand might change from the different year. We have a lot of products. So when we are defining the portfolio, we should be able to try to understand which will be the impact of different portfolios and how that will impact not only my production efficiency, but also my response to the market, not only in terms of lead times, but also in terms of service level. So we developed a project that could address this problem by using an optimization model that would both propose which is the optimal production strategy, so if a product should be made to stock or should be made to order, but also based on this strategy, how can I fulfill the market? Which is the lead time that I can propose? Which is the service level that I'm expecting to have? So based on this model, we are able to test different scenarios, understand which is the impact on the results, but also something very important, to conduct some what-if analysis to understand which will be the impact of the different scenarios that we are testing. So it starts with understanding which is the impact of having different make-to-stock and make-to-order combinations. As we all know, when we have it's not working, but when we have a mix that is mainly composed by make-to-order products, we can reduce a lot our stock costs, but we'll have much more constraints regarding the order costs. When we go to the other way around, we'll have more stock costs, but the cost of fulfilling every order will reduce. The secret is in trying to combine the both strategies and try to find the ideal mix. When we are trying to find the ideal mix in this context, we are not only talking about the finished product. When you are talking about these wood-based products, we have different boards, we have different papers, and we should be able to understand by each product in the chain of production if it should be made to stock or made to order. And in the case of the finished products, if we could combine different make to stock or make to order strategies in our raw materials in order to fulfill then the finished product. So we built it with an optimization approach. We want to optimize different KPIs as the setup times and the number of setups that will impact our setup costs, our level of stocks and related costs, our utilization of the lines, the lot sizes that we produce that impact a lot our utilization in the lines, the utilization that we give to the storage. Here was one of the main concerns. We have limited space of storage, and we need to find a solution that complies with the overall storage capacity. And in the end of the day, we want also to optimize our lead time and our service level. So we need to comply with a set of constraints regarding production. We need to comply that between stages there will be a need to wait before the next production to start. We need to consume capacity regarding changeovers and regarding the production. We also need to ensure that the production of my product is aligned with the production of the family of my products. So everything should be synchronized in terms of production. But we also have storage rules, like some products only can be fed in some type of storage. I have limited space and I have a limited validity of time, so I need to ensure that my stock levels also fulfill this validity. In terms of commercial, I want to be able to comply with historical lead times and historical service levels that I have. So what were we defining? Obviously, I was explaining in the beginning the make to stock and the make to order strategy for each product. That is obviously, but a lot of other very relevant insights. The product frequency and the block frequency, so the family of my product, how often will it be produced, which is the cycle stock and which is the safety stock. So not only if a product should be make to stock, but also the related stock to this product, and in the end of the day, which is the lead time that I will propose to the market with this strategy. One of the most important parts in defining all this is being able to modeling the queue in my lines. So we were trying to find the bottleneck of our lines, like the line to the steak during the lunch today, and what we were trying to understand, which would be the impact of a product being made to stock or being made to order. We assume that a product that is made to order, it needs to go directly to the queue. A product that is made to stock, we can have stock and fulfill our customers, but then when my stock is over or I'm below my minimum stock levels, I need to go to the queue line, and I need to wait to start my production. So by combining different mix of make to stock or make to order products, I will have different queues. And by having different queues, I will have different utilization of my lines and also different standard deviation of my queue lines. And what will that impact? If I increase my utilization, I will increase my queue time, I will increase my standard deviation, and what will happen? My service level for the make-to-order products will reduce, I will improve my stock levels, and with that, I need to balance the level between make to order and make to stock to find a good fit between line utilization and stock levels. So, as you can imagine, optimization is the best way to solve a problem like this. Typically, this is a non-linear problem. We need to linearize this problem in order to solve it with mathematical formulation and use Gurobi. As I said, this is a tool that could also be used to perform what-if scenarios. So we have production levers, like how can I change my what-if and how will that impact my mix. I have product parameters. I can, for instance, change the forecast of my products and understand what will be my impact in the production. I have storage parameters. For instance, if I open a new storage, what will be my impact, not only in my production KPIs, but also in my commercial offer. Change, of course, the portfolio. As I was saying in the beginning, it was one of the main constraints, and by the end also consider non-operational metrics, such as we know that the transportation is something that might impact my proposal. So if I change my transportation lead times that were also that were out of the scope of the project, what will be the impact in my holistic offer to the market. So regarding the simulation optimization model, we built a web interface at LTP Labs where we could trigger different scenarios. Those different scenarios had an input, so a parameterization file that you could use to set those different parameters. That parameterization file is supplied to the analytical models developed using Gurobi through Databricks, and by the end of the day, we have a production strategy plan. One of our main concerns during the project was the integration with the company ERP. So everything then is at the company's database and directly connected to the ERP. So as I was saying, we have a parameterization file when we can set all the input data, but also define the scenarios that we want to test. And then we have, of course, all the outputs that are required to perform the output analysis, not only a granular level, such as the product level, where we can understand which is the strategy, which are the costs, which is the stock, a very detailed analysis, but also a Power BI dashboard with all the main KPIs, so that we can understand and compare the different scenarios. So now I think it's time for João to present some of the results and some of the things that we are testing.
Before, to explain, we had a challenge here. How could we validate if the mathematical model is delivering the results we expect? So first, we started by seeing if the model is emulating correctly our production process, to see if it has all the production lines, all the inputs. But then, and we spent some months in there, and it was always missing some detail. And that can go up to a certain point, because then the mathematical model becomes too complex and it takes too long to run. So when we get to a certain stage, we decided to start validating the results to see if the results were respecting the trade-offs that we were expecting. So we compared the model results with our current situation. If the model is recommending better solutions than the one we had, and how much we were gaining in efficiency and in cost reduction and increase of the service to the clients. We used, so this is a static model, so it runs with a certain kind of forecast. So we have to, when we implement it, we have to run it periodically to update to the new trends in demand. So for that, we use the forecasting models, values that come from our SNOP that has a forecast model inside. So our main restriction is the warehousing space. So we did run also some scenarios to see if we incremented the warehousing space, how much did we gain in service level and in terms of availability of the production lines. So this tool allows us to test various scenarios and see which are the directions that are best. But the base one was to compare with the current situation. And these are the main results. So we spent a couple of months fine-tuning the model with the results, because it was not providing the results we were expecting, and it was not going in the directions we felt that were that made sense. So it is very important that the users get confident in the model and that know how to explain the trade-offs that a model is doing to the managers, to the decision makers, because in the end, this tool will give recommendations that will be validated by decision makers and then put in practice, because this will change even commercial strategy, business rules, and might also lead to investments in warehousing, and that has to be well quantified. So basically, going to this, the model is proposing, as we expect, increasing the MTS and serving more demand from the MTS, a big increase. The average stock doesn't increase much because we have limited space. We were already using almost full space in the warehouse. And one key aspect for production, it reduces the changeovers and the stoppages in the lines. That we're expecting that. Some improvement in the lead times. And if we do the calculation of stock-related costs, like capital costs and obsolescence costs, and compare them with what we gain for not stopping the line so much with setups and changeovers, there's a reduction in total cost of 12%, and this is a good result for us. We are now in the implementation phase, and maybe that will lead to some fine-tuning to the model, and we will see. But we are happy with these results.
Okay, so as João was saying, now we are in the implementation phase. And since this is not a one-shot run of the model, we need to ensure the long-term success of the model and also its sustainability. So change management is key for the implementation and the long-term success of the project. So we have conducted initially the model and data validation. That is key for the users to get confident in the model. We need to define which is the governance of the utilization of the model. So it needs to be clear who uses each information, which is the main stakeholder, who is responsible to update, and where. Knowledge management is also key. So we need to ensure that the knowledge is transferred completely to in this case to Sonae Arauco and to the main team, and also having an ambassador as João is key. Having someone that is responsible for the model inside the company is of paramount success, of paramount importance to ensure the long-term success of the project and also its utilization. So I think we covered most of what was important regarding this project. We developed an optimization model where the key decisions were the production strategy, the frequencies, the stock levels, and lead time proposition. We implemented the web-based solution to respond to the evaluation of different scenarios, and we also conducted the results analysis, the change management that is key to the long-term success of the project. If you have any question, feel free to ask.